Now, dear children, we will solve two numerical problems from this chapter, nuclear fission and nuclear fusion, and with this numerical your chapter get completed. Okay, now we do one of the numerical problem came in ISC 2013, one of the year. Okay, and this is a problem based on fusion reaction. What reaction? Fusion reaction. As I said, fusion reaction can occur in sun, stars and all. Okay, so the problem says that in a star, 3 alpha particle, 3 alpha particle means a helium nucleus He2 4 nuclei fuse together to form a carbon say 612 nucleus, one of the stable nucleus of carbon, isotopes of carbon. So compute the energy evolved. So when 3 alpha particle, a lighter nuclei, if they combine or fuse together to form a carbon say 612 nucleus, heavy nucleus, then some energy will liberate under the reaction called fusion reaction, and that energy we need to calculate. And in this question what actually is given, the masses of helium He2 4 atom is given, and the mass of what, carbon 612 atom are also given, and that masses are nothing but 4.002604 U means at unified atomic mass unit for helium atom, and 12.000000 U for the mass of what, carbon 612 atom. So what we need to calculate? We need to calculate the energy evolved. So in order to solve this problem, okay, let me just first write the same statement in the form of equation or in the form of reaction. In a star, 3 alpha particle are fused together. So alpha particle means He2 4 is fused together, means combined together in this way. So total how many alpha particle are fused together? 3 alpha particle. So 3 alpha particle are fused together to form carbon 612 nucleus. But along with this, what will form? What will evolve also? Energy will also evolve, and that energy we need to calculate. But you know why energy will get evolved under this reaction? And this is a what reaction, as I said? Fusion reaction. This is a fusion reaction occurs in star. Now the main reason that the energy evolved is because when you measure the product of when you measure the mass of this productant, this is called product, and these are the masses of what, reactant. This quantity are called reactant. And when we measure the mass of the reactant and the mass of the product which is formed is always less than the mass of the reactant. So there will be a loss in mass, and this loss in mass is actually appear in the form of energy, okay, as per Einstein's equation, and that energy only we are going to calculate. Okay, now to calculate energy, first I calculate the mass defect, and this mass or loss in mass also at what, also called what defect? Mass defect, and the symbol is delta M. Mass defect means nothing but the loss in mass, but this mass defect we always calculate as sum of the what? Sum of the masses of reactant minus the mass of product. The mass of what? Product. So sum of the masses of reactant minus mass of product measure the what defect? Mass defect. Okay. The sum of the masses of reactant means the mass of 3 helium atom. So it is nothing but the mass of how many? 3 He2 4 atom minus the mass of product. This is the mass of product, means the mass of C612 atom. Because your product is what? Carbon 612. Now, what is the mass of 1 helium atom? The mass of 1 helium atom is 4.002604 U, but we are measuring the mass of 3 atom, means I multiply by 3. See, 1 helium atom mass is 4.002604 U, but there are 3 helium atom which are fused as a reactant. That's why to calculate the mass of 3 helium atom, you just multiply by 3. Minus the mass of carbon atom. What is the mass of carbon atom? 12.000000 U. Okay. Now we can multiply this quantity. If we do multiply these two quantity, we get approximately 12.007812 U. So when we do calculate with the help of calculator, multiply this quantity, we get this much. This is the mass of the reactant minus 12.000000 U. So if we subtract this two quantity, we get 0.007812 U. So what is delta M? This is the mass defect, and this mass defect delta M equals to 0.007812 U. So this is the mass defect. But you know this mass defect is only appears in the form of energy. So I write down therefore the energy evolved. Therefore energy what? Evolved is nothing but mass defect into c square. So we just multiply by mass defect into c square. And you know what is the mass defect? 0.007812 U into c square. Now to calculate this energy directly in mega electron volt, what we need to do? We multiply by the value of 931.5 mega electron volt. Because when there is a mass defect of 1 U, the energy evolved will be 931.5 mega electron volt. But what is the mass defect out here? 0.007812 U. Your mass energy evolved will be simply multiplied by 931.5 into this mass defect. So if we do calculate this two value with the help of calculator, we get approximately 7.277, and the unit is mega electron volt. Now see children how much energy that get evolved when three alpha particle fuse together to form carbon nucleus, okay, in stars under fusion reaction. 7.277 mega electron volt. So this is one of the numerical problem number 1, based on fusion reaction. So we will do another numerical problem that also based on fusion reaction. Now we will solve last numerical problem, that is problem number 2. And this is one of the problem which also came in ISC 2006, one of the year, okay. And the problem is also based on fusion reaction. And problem number 2 says that the following equation, represent a fusion reaction. What reaction? Fusion reaction, okay. And the reaction is given out here. Okay, let me just do the solution of this question. Okay, let me write the reaction. What is given? H12, one deuterium atom, hydrogen atom, combined with another deuterium, tritium, one of the isotopes of hydrogen, combined to form helium nucleus, He2,4, with neutron, with neutron how much? N01 and Q. Q is the energy evolved. Okay, so this is one of the fusion reaction. Okay, and where Q is the energy release under the reaction, under this fusion reaction. Okay, the question says that given the mass of hydrogen atom, H12 atom, this hydrogen atom mass is given 2.04101 U. Similarly, the mass of this tritium atom is given, H13 atom is 3.016049 U. And the mass of this helium nucleus, He2,4 atom, is 4.002602 U. Okay, and even the mass of this neutron is also given, that is 1.008664 U. Now from this what we need to calculate? Q. Q means the energy which is evolved or released in the reaction. So this question is similar like question number 1, because this is a fusion reaction and these two are called reactant. These two are called reactant and these two are called product. And you know, when a fusion reaction takes place, we always observe that the mass of the product will be less than the mass of the reactant. And that means when from reactant, when product is formed, then that product mass will be less than the reactant, the mass of the reactant. So that means there is a loss in mass, and this loss in mass is only called mass defect. And due to this mass defect, there is an energy which is calculated, and that energy will be what? Q. Okay, so under this question also we calculate the what? Mass defect. I write directly mass defect. Mass defect. And mass defect out here also we mark by symbol delta M. And as I said, mass defect is nothing but mass of the reactant, masses of the reactant minus the masses of the product. So I write down masses of the what? Reactant minus the masses of the product. Okay. Now masses of the reactant means the mass of He2. So I write down the masses of what? The masses of H12 atom plus H13 atom minus masses of the product means the mass of what? The masses of what? The masses of He2,4 and neutron. Now these two masses can be added. So you know what is the mass of H12 atom? Helium hydrogen atom mass is how much? 2.0410 or 2.04101, okay, U, plus the mass of tritium. Yes, tritium mass is also given 3.016049 U, minus, okay, right, in bracket, the mass of this helium nucleus is how much? The mass of helium nucleus, as you know, it is 4.00260 U, plus, and what is the mass of neutron? 1.00866 U. Okay, now we can add these two masses. If you add with the help of calculator, you get approximately 5.03015 U, minus, add these two masses also. If you add, you get even 5.0112664 U. Okay, now we subtract these two masses. When you subtract these two masses, it will be almost 0.0188836 U, and this mass is actually called the mass defect. So see, what is the mass defect? Delta M equals to 0.0188836 U. Now with this mass defect, the energy will evolve. So energy release, calculate what? Energy release, and that energy release marked by symbol Q equals to mass defect into C square. And you know what is the mass defect? 0.0188836 U into C square. So we do in the simpler way as we have done for problem number 1 also. We multiply this 0.0188836 by the quantity, that is 931.5 megaelectron volt. But children, remember this value when you get this type of question. If you get in the ISC examination, sometimes the value may not be given 931.5 megaelectron volt. It may be 931 megaelectron volt. So whatever value will be given, equivalent amount of energy is given for 1 U, that value only you need to multiply with the mass defect. So you do multiply this quantity, you get approximately 17.59 megaelectron volt. Means we can round up this to 17.6 megaelectron volt. So look at the energy that will be released when H12 and H13 hydrogen atom fuse together to form alpha particle, neutron which form with the release of energy. So this is the problem based on fusion reaction. So I solved total 2 numerical problems. I think these 2 numerical is more than sufficient to solve based on fusion reaction. So we have completed the chapter. So now we'll start the last unit, that is unit number 9, as for reduced syllabus, okay, semiconductor devices, and that we do from next class. Thank you so much.